Hello and welcome to my Embryology series. Now we'll be covering the practical classes in the Embryology course, so not the theoretical, please keep that in mind. I'll be having 3 classes for Colloquium 1 and 3 classes for Colloquium 2. Following these, I will also be doing 2 test yourself videos. So in those videos you can test yourself, like the name suggests, and you can see where your skills line up. And then if you feel like you're falling behind on something, you can come back to these videos and get a more in-depth review of all of the slides and structures that you need to know. Keep in mind that these videos might be outdated, so double check with your practical professors and make sure that no slides or structures are being left out or added in unnecessarily. During my time taking this course, I had Professor Rona as my professor, so this whole documented these videos are heavily influenced by what she taught us. But I did go through student notes taken from Professor Vaivad's classes as well, and I have added them in, and I will be pointing out when there are clear differences that I've found between the two, but do keep in mind that it barely happens, especially in Colloquium 1. There are some key differences in Colloquium 2 that I will be bringing up. Now, why am I doing these videos? So I found it very easy to memorize structure names, but not to actually identify structures, especially considering the fact that we're now dealing with real microscope slides. So during the Colloquium or practical part of the Colloquium, you will be looking at real microscope slides, and you'll have to definitely identify those microscope images in order to gain points. For example, when it comes to this slide, it might look very odd in a real microscopy setting. It might look something like this, right? So because of the microscope and how heavily zoomed in it is, it's going to be hard to get the full picture, and therefore I'm here to kind of help you identify what you're looking at and give you some tips and signifiers of the slides that will hopefully gain you some points. Without any further ado, let's start with the slides. Now, when it comes to cat ovary and cat uterus, the only really important slide was the cat ovary, and even then it was only there for you to get a overview of the slide and the structure that we're actually interested in, which is the follicle, but we'll get to that in a second. Cat uterus wasn't as important for us in the Colloquium. Instead, it was the human uterus, which looks something like this. Now it looks different because it's cut way differently. It's cut like this instead of being held together like this. So again, cat uterus not as important, but very interesting for you to actually see it from a physiological setting. Cat ovary instead, again, only really important for you to get an overview of it, and then once they zoom in into the actual slide that it's important, you will understand way better what you're actually looking at. So for the cat ovary, it kind of looks like it looks very oval in shape. It has all of these hilum and the oviduct area, and it contains obviously all of these follicles. Now these are rest structures from a previous histology colloquium, so those are not as important. The important parts are all of these highlighted in pink, and I'll get to them in a second. So once they show you the entirety of the ovary, looking something like this in the demo lab or in the microscopy slide, they will zoom into this slide that is actually important, which is the egg follicle. And now the egg follicle looks different, but there are some main structures that I would like to point out before we start. Let's actually get it here as well. So here's the ovary. Now you can see that I've already annotated here. So the ovary contains, I would say, 3 main structures. It's the empty space here that sometimes exists, sometimes doesn't, which is called the antrum. And it's not really empty, but it looks empty, right? It's all of this white area. And then it also contains the fabric that is kind of holding it all together. So all of these cells that goes around the follicle is called the columnar cell ring. And this structure this particular structure exists almost in every sort of demo lab image that we have of the egg follicle. So we can see it kind of here. This would be it. All of this would be it as well. So almost always we can see the columnar cell ring taking place. The most important structure would be the oocyte 1, and you have to write in oocyte 1. So a lot of people make the mistake of figuring out what the oocyte is. So sometimes people would say that this is the oocyte, sometimes people would say that this is the oocyte, but in fact the oocyte is the egg cell with the cytoplasm, with a clear cytoplasm right around here. Now this might appear like it has a cytoplasm, but this in fact is the nucleus of the oocyte 1. Nucleus, and then this would be the oocyte 1. Surrounding the oocyte 1, we have another structure. It doesn't appear always in images. For example, in the demo lab images, we didn't really have it. You can see the oocyte being all of this, and then the nucleus being the thing in the center. And then surrounding, we have this white area. Sometimes we don't really have it all the time, but coming back to here, we actually have this white area in this image called the zona pellucida. Lucida meaning light, so that makes sense. Zona pellucida. Another structure that we don't always have is the crown that is like acting as a hat to the oocyte, and this is called the corona radiata. Now the corona radiata always sits atop the oocyte, separated only by the zona pellucida. Those are the structures that are very important for this colloquium, but the zona pellucida might not appear all the time. Same with the corona radiata, same with the antrum, the empty space, right? But what I would say is the most important is the columnar cell ring, aka the egg sac, the cells that line up all of this, surrounding the egg follicle, and the oocyte 1. Maybe also the nucleus would be important, but what's most difficult for these slides is actually identifying where the oocyte 1 ends and where it begins. So that would be that, and then down here we have this being the oocyte 1, this, and this, right? So again, they'll show you an image looking like this. They'll zoom in to one of these follicles showing you this, and then in this case I would say the only important parts would be the oocyte 1, the nucleus, and the columnar cell ring. But sometimes you can see the antrum, like you can see here. At times you can also see the corona radiata, which you can see here, and the zona pellucida, but sometimes you can't. All of these other structures are again rest structures, or the follicle could be important, but the rest structures taken from a previous histology colloq, so they're not as important, but I still added them here so that you can see the difference. Okay, that was the egg follicle real fast. Now we're going to get into a little bit more of a unique structure, namely the germ layer. Now, we have two slides in this colloquium that look very much alike. I'll show it to you in a second. So these two would be a good example. This slide and this slide are the same, but they're at different developing times, right? So this and this would actually be two different slides for your colloquium. This is more evolved version of this. And you will have to name them differently. This being a germ layer, earlier version, and this being the embryonic folding phase, right? The best way for me to tell you how to identify them is by looking at the shape. Now, the germ layer has a more straighter shape. It doesn't look like it's folding in on itself, while the embryonic folding, like the name suggests, is folded in. It kind of looks like a cowboy hat. Has this cloud shape, right? Maybe like a frog, maybe like a cowboy hat, maybe even like a clover. And that is the main difference between embryonic folding and germ layer. Now, getting into the structures, I think that the germ layer has the most amount of structures. But thankfully, if you split it in two, the structures are symmetrical, so you will have the same structures on this side as you will have on this side, thankfully, besides one specific structure, but we'll get to that in a second. So the most iconic, most identifiable structure within this layer, germ layer slide, is this opening in the middle, this dark area here called the neural tube. It looks like a pair of lips. It's also in embryonic folding. So again, this is folding because it looks like a clover, right? It's folded in, while this is the germ layer, which are two different slides. Don't mix them up, but it exists also in the embryonic folding. We'll get to that in a second. So this big opening called the neural tube, and then in the center we have this slit called the neural, whoa, that's not how you spell neural canal. Easy. The two easiest structures within this slide: neural tube, which is all of this, and then the neural canal in the middle. Unfortunately, not a structure that is mentioned in the colloquium that often because it's so easy. Underneath, always underneath, we have this specific structure. Now, sometimes it can appear oval, sometimes it can appear round like it does in embryonic folding. Here, oh, that's still germ, so we only have germ layer. But sometimes it can appear perfectly round, sometimes it can appear oval, and it's always underneath, directly underneath the neural tube. Now this is the notochord. Notochord. It's also called the chorda dorsalis if you want. The neural tube is made up of something called the neural epithelium. It's not as prioritized for this colloquium, thankfully, but double check again with your professors just to make sure. Now, to each side of the neural tube, we have two main blobs. I call these pom-poms because they look very not rigid, but very fluffy at the ends, almost like it's holding two pom-poms, like a little cheerleader. These are called somites, which is the easier name for them, but they're also called the paraxial mesoderm. Most people go with somites, so you can see them here as well. Paraxial mesoderm on either side, aka somites. I go with paraxial mesoderm because some other structures in the same slide also have the name mesoderm in them, but you can go with somites. I think that will be fine. Again, double check with your professor just in case. So you can see it here as well. This would be the neural tube, the neural canal, and then the pom-poms next to it being the somites. Fairly easy, right? Here is the same, the neural tube, the neural canal, and then the pom-poms next to it, the somites. And then underneath we have the notochord, of course. Now, following the mesoderm, the paraxial mesoderm and the somites, we have this bridge, and this bridge connects the somite or the paraxial mesoderm together with this other structure that's fairly big and has an opening. We'll start with the bridge first. Now the bridge is called the intermediate mesoderm because it's the middle part of the paraxial mesoderm and this structure, which is called the lateral mesoderm. Easy, right? Now don't mix it up with this slug-like structure at the top. This structure is directly connected to the somite and the lateral mesoderm, and therefore we call it the intermediate mesoderm. It acts like a bridge between them both. You can see it on the other side here. So we have the pom-pom, the somite, directly connected with this bridge called the intermediate mesoderm, which follows up with this lateral mesoderm right here, not this structure right up here. We'll get to that in a second. So the thing that directly connects the somites, the mesoderms together. All right, now we get into the lateral mesoderm, and the lateral mesoderm has 2 or 3 components to it. So the entire thing is called the lateral mesoderm. The top part, this part, is called the, I think it's somatopleura. Let me double check. Yeah, okay, perfect. The top part is called the somatopleura. And the bottom part is called the splanchnopleuра. Splanchnopleura. Easy to remember, right? So they are quite difficult names, but again, the naming isn't as difficult as actually identifying where they're supposed to be. So lateral mesoderm is this entire thing, and then the top layer being the somatopleura, the bottom layer being the splanchnopleura. And then we have the opening. Now the opening has a name that I might not be able to pronounce. It's called the intraembryonic, and then this word, coelum, is how I pronounce it, probably completely wrong. But the intraembryonic coelum is the center area, the opening of the lateral mesoderm. Now again, it has splanchnopleura as the primary layer, the top layer, the somatopleura as the top layer, the splanchnopleura as the bottom layer, and then the opening being called the intraembryonic coelum. Same thing on the other side, lateral mesoderm, splanchnopleura on the top. I did it again. Somatopleura at the top, splanchnopleura at the bottom, and then the intraembryonic opening, coelum opening, right? We can see it here as well. Somatopleura, intraembryonic coelum, and splanchnopleura at the bottom. The entire thing being called lateral mesoderm. Here as well we can find it. This would be the somatopleura, this is the intraembryonic coelum, splanchnopleura, and then we also have this bridge, which is the intraembryonic mesoderm, and then the somite/paraxial mesoderm. Quite easy structures for the germ layer, right? Okay, this is my perfect image of the germ layer. So we have the neural tube, the neural canal, the notochord, the somites on either side, and then we have the the intermediate mesoderm here, and then the lateral mesoderm, the top being the somatopleura, bottom splanchnopleura, and then the intraembryonic coelum. Now we come, let's cover some other structures that are a little bit easier. So we have a top layer of this entire germ layer slide. So the top layer is called the ectoderm, and the bottom layer is called the endoderm. What I would like to point out before we continue with the more difficult structures of the slide is that in the colloquium, for during our colloquium at least, the slide was upside down. Now this is something that is completely all right to do in the colloquium. You need to yourself differentiate the ventral from the dorsal surface. What I find easy is looking at where the notochord is placed. So the notochord needs to be directly underneath the neural tube. That is the bottom of the slide. So once it was upside down, I could see that the notochord was on top, meaning that in this case, this would be the splanchnopleura and this would be the somatopleura, right? Because everything was upside down. Same thing with the outer and inner layer. This would be the endoderm and this would be the ectoderm in that case. So again, please make sure to see where the notochord is placed before you start naming all of the structures. Because it could in fact be upside down. Okay, now for the two more interesting slides or structures. We have this that sort of looks like a blood vessel, if anything. I think that would be an easy distinguisher. It is kind of like a blood vessel, right? And this blood vessel is called the aorta dorsalis. Aorta dorsalis, or the dorsal aorta. And it exists in almost every germ layer slide, including the more developed embryonic folding slides. You can see them here. Now, how do you differentiate this opening, the aorta dorsalis, from the intraembryonic column opening? The aorta dorsalis is unique because it includes all of these cells, these nucleated cells, called the nucleated erythroblasts. And this is a very colloquium-prone structure, I would say. So the nucleated erythroblasts exists within the aorta dorsalis, and they're unique because they're a very primordial blood cell that contains a nucleus. So be very mindful that these cells and within the aorta dorsalis is something that might come up in your practical colloquium. Here we can see them. This is the aorta dorsalis opening, maybe even this. And then we have all of these specks that are nucleated erythroblasts. We can also see it in the demo lab slides. We can find them here in the germ layer. So you can see them if we zoom in. So this would be a zoomed in version of this, like so. So that is the lateral mesoderm. We have the intermediate mesoderm here, the bridge between the somite and the lateral mesoderm. The somatopleura at the top, splanchnopleura at the bottom, the intraembryonic coelom, and this would be the aorta dorsalis, and then within it we have these nucleated erythroblasts. So that is easy enough. Again, this we know is right side up because we have the notochord at the bottom, not the notochord at the top. So this would be the ectoderm in that case, and this the endoderm. All right, so that was the aorta dorsalis and the nucleated erythroblasts. Now we get into the most difficult structure in this slide, and that is the difference between the nephrotome and the ductus mesonephricis. Now remember when I talked about the intermediate mesoderm, and we talked about this little slug-like creature that we didn't want to mention yet. But this that sits on top of the intermediate mesoderm is called the ductus mesonephricis, but only if it has an opening in the middle. If it doesn't have an opening in the middle and it's completely homogeneous like this, it's closed, it's instead called the nephrotome. So again, it has a completely different name depending on if it has an opening in the middle, making it out to be as a ductus mesonephricis, or completely closed, becoming the nephrotome. Here, it kind of has an opening in the middle, so this would be the ductus mesonephricis. Right here, we can see one that has like this little lighter pixel in the middle, so this would be the ductus mesonephricis, while this one that sits on top of this intraembryonic, the intermediate mesoderm, this little guy is more of a nephrotome because it doesn't have any opening in the middle. Here I would say this, because I don't see any opening in it, this would be more of a nephrotome. The person said intermediate mesoderm. I would say this is more intermediate mesoderm, and this would be the nephrotome. Okay, looking at the demo lab slides, could we find a nephrotome here? I would say both of these sides have a ductus mesonephricis. So here we have a very, very fragmented somite, and then we have the intermediate mesoderm, and then on top of the intermediate mesoderm we see this little slug-like thing with a hole in the middle. This would be the ductus mesonephricis. Same thing over here, little thing with a hole in it, making it out as a ductus mesonephricis. Here is more zoomed in. Like we said, this would be the intermediate mesoderm, and then here we have that little thing that sits on top of it, and because it has a little lumen, it's a ductus mesonephricis. Okay, those are all of the structures for this slide. Now continuing on with the more evolved version of the germ layer, the embryonic folding. Now, like I said, the embryonic folding kind of looks like a three-headed clover like this. It has folded in on itself, and another signifier that we're looking at intraembryonic that we're looking at the embryonic folding is the position of the notochord. So in germ layer, the position of the notochord was almost at the end of this entire structure or slide. So what comes after the notochord is the endoderm and then nothing, right? While in the embryonic folding, the notochord being more circular here, it has been pushed up. So we have more things that comes between in between the notochord. Yeah, the notochord and the endoderm. So that is another difference where that you can find between the germ layer and the embryonic folding. Let's see here. Yes, so this is another slide showing the embryonic folding. Again, this time it looks like a car, almost exactly like a car. So here it's not as clover shaped as we'd like, but this is definitely the embryonic folding. And for the embryonic folding, we don't have any somites anymore, so these pom-poms are completely gone. Instead, they have developed into these two structures, and these structures, if we delete them, it looks like a somite, but it's not really. It's a developed version of it, and they can be split into two. Now we have this outer layer that is directed towards the outside of the slide, and this is called the dermatomyotome. Dermatomyotome. We can see it here more clearly. Dermatomyotome. And then the internal layer, this area that is surrounded by the dermatomyotome, but the internal layer is called the sclerotome. So instead of the somite, we have the dermatomyotome and we have the sclerotome. We still have the lateral mesoderm here. We don't have the intermediate mesoderm anymore. We still have the notochord, of course. We still have the outside layer known as the ectoderm and the above layer, and the underside known as the endoderm. And we still have the aorta dorsalis. How do we know that this is aorta dorsalis? Because we can see these nucleated erythroblasts. Again, very important structures. We can also sometimes see the ductus mesonephritis here as well. Here you can see another example of it. This would be the nodal tube, the nodal canal, the notochord, and then here we have the dermatomyotome appearing like this, almost like a slug, and then the middle part instead being the sclerotome. So this is the dermatomyotome, that would be the sclerotome. So sclerotome, dermatomyotome. And then the aorta dorsalis, because they have all of these nucleated erythroblasts, and the lateral mesoderm with the somatopleura and the splanchnopleuра. And also, of course, the intraembryonic column. That is also another structure that definitely may appear in your practical classes. Here, giving you another example, the dermatomyotome, the sclerotome, aorta dorsalis with nucleated erythroblasts, and lateral mesoderm. Okay, that was all for the embryonic folding and the germ layer. Now we're going to get into sperm, both guinea pig sperm and human sperm. Now when it comes to human sperm, it's probably one of the most easier structures to remember. However, the slide during the practical colloquium is very difficult to identify. But hopefully I can give you tips enough to identify it. Why is it difficult to identify? Because the microscope is not as it doesn't have like a clear HD rendering of the slide that it's looking at, so it might just look like a cloud of nothing, like a pink cloud of absolutely nothing. You can kind of see it here. So again, this is what might appear on your colloquium, and then you might start panicking because you can't really see the very characteristic sperm shape of the spermatozoa. So if you see something that looks like this, where it can appear pink, sometimes it can appear grayish as well, but something like this zoomed in, this is what you get, and then more zoomed in, this is what you get. You will not be able to see the spermatozoa as clearly as you'd like, especially for human sperm. But that's why I'm here to tell you that if you see something like this, where there's a cloud of just small cells appearing randomly, sometimes they're in a blob on the side, this is in fact human sperm. And you won't really see any other slide that looks like this, even though you can't really identify the sperm cells as easily. So going back into sperm cell territory, here we go. Again, this is how it might appear in the colloquium. As I said, very odd. But one of the more important signifiers for human sperm is the cells that are not actual spermatozoa, specifically the human urethral epithelial cell and the lymphocyte. So we have two types of cells besides the spermatozoa in human sperm. We actually have more than two, but two that are important: the urethral epithelial cell and the lymphocyte. Now, the urethral epithelial cell appears as a very big, almost tick-like cell. So it has this big cytoplasm surrounding this very smaller nucleus. We can also see it here. So here there's a big nucleus and then the cytoplasm surrounding it. A very, very unique cell, and you will be able to spot it from a mile away. This is something that is, in fact, very clear during the practical part of the colloquium. So if you see a cell that looks like this, surrounded by a blob of cells that you can barely distinguish as spermatozoa, then definitely you'll know that you're in human sperm territory, and this would be the urethral epithelial cell. The other cell that I mentioned is the lymphocyte. Now, the lymphocytes appear as the human urethral epithelial cell, only that they don't have the surrounding cytoplasm. So here you can see a lymphocyte, here you can see a urethral epithelial cell. So you can see the nucleus plus the cytoplasm. So nucleus plus cytoplasm, or big cytoplasm, equals the urethral epithelial cell. While the lone nucleus with no cytoplasm, or no visible cytoplasm, is the lymphocyte. Hopefully that's easy. Some people have a hard time with that, but again, if you just see a big black dot with no cytoplasm, that would be the lymphocyte. If you see a big cytoplasm, pinkish cytoplasm with a nucleus, that would be the urethral epithelial cell. Now we have another type of cell called the neutrophil. The neutrophil is smaller than the lymphocyte and it has this split-like nucleus, almost looking like the character of Baymax. Take this with a grain of salt, but I doubt you'll get the neutrophil in your practical colloquiums. Why? Because the human sperm slide is so out of focus and so chaotic that you will barely be able to find the neutrophil. Maybe like this, or this could be the neutrophil, because you can kind of see like the nucleus appearing segmented. But again, I doubt they'll be during the colloquium. They're very fair, and they try to make the slide as obvious as possible, and therefore I don't think that they'll make it this hard and show you a neutrophil where you can barely see that it's a neutrophil. Like here I annotated this is a neutrophil, but it's probably not. You can barely see what it is. So again, the neutrophil might not appear in the colloquium, but keep that in mind just in case. Another cell that is iconic for human sperm is obviously the spermatozoa. Now you don't write spermatocyte or the sperm cell, you write specifically spermatozoa. And they appear like so. They have a classical sperm-like shape, and they have some segments that you have to know. First of all, the head of the sperm. Well, we'll get to that in a second when we look at the guinea pig sperm, because it's a lot more clearer. Now compare this with the guinea pig sperm that looks like this. See how much clearer the guinea pig sperm is compared to the human sperm? Even this, you can kind of see it. Oh no, that's the human sperm. Here, there we go. Very clear shaped spermatozoas that you can actually identify each segment of. So first of all, we have this crescent moon tip of the spermatozoa, known as the acrosome, with all of the enzymes that it needs. And then the entire head is of course called the head. We have the neck, which separates the head from the tail. And I think that's it. And then of course the nucleus, which sits on the center of the head, or the bottom of the head. For guinea pig, we actually have two types of spermatozoa. We have a multi-tailed spermatozoa, which has multiple tails, and then we have the single-tailed spermatozoa, which only has one tail. Now, we do have sometimes multi-tailed spermatozoa does appear in human sperm, but not as abundantly as it does in guinea pig. So therefore, if you see like a slide with a lot of spermatozoa with a lot of tails, then you definitely know that we're in guinea pig territory. For human sperm, again, very chaotic, and usually just single-tailed spermatozoa. But you definitely can see some lymphocytes, you can see some urethral epithelial cell. This exists in human sperm, but you can't really see it in guinea pig sperm. Okay. And that's how you know that you're in humans. So if you get a sperm slide and you see the urethral epithelial cell or the lymphocyte, you definitely know that you're in human sperm and not in guinea pig sperm. Okay. The last thing about human sperm that I would like to mention, other than the different segments of the spermatozoa, is the name we use to describe a bunch of spermatozoa that is stuck together. So this area we call the conglomeration of spermatozoa. So you can call it this area as well. So if they show you during the colloquium this, where they show you several spermatozoa bunched together, that would have this name, or you need to write this in order to gain all the points. Okay, that's it. Again, the most important, well, we can look at the demo lab as well. So like I said, during the demo lab, this is how it might look like in the colloquium. And again, it looks very chaotic, but when zoomed in, you will be able to see the human urethral epithelial cell. Only here, you can only see the cytoplasm. The nucleus is hidden by this mouse, but the nucleus would theoretically be here, and then we had this cytoplasm, so we'd know that this is the urethral epithelial cell. While this, which only has a dark nucleus, would be the lymphocyte. Here we can see it as well. This would be the lymphocyte. We don't really see a urethral epithelial cell here, but here we can see the conglomeration of spermatozoa because they're bunched together like this. Okay, so if you see anything that looks like this, thank you, motorcycle. You'll know that you're in human sperm, specifically if they ask you about those classic cells. Now, when it comes to the human uterus, there are two phases that you need to know about. You need to be able to distinguish which phase the human uterus is at. Is it the secretory phase or the proliferation phase? Now, the only real area we're looking at in order to determine these phases is the top lighter area of the human uterus, known as the endometrium. This is the area that has all of these glands in them. Now, for the secretory phase, these glands are more elongated, worm-like, river-like. They are directed towards the lumen of the human uterus. While for the proliferation phase, while there might be some glands towards the bottom that are elongated, mainly we're looking at the top half of the human uterus, and they are more compact and rounded. So compare this, or these glands for the secretory phase, with something like this, where the glands are more compact and rounded. Another real important factor about this specific slide in the colloquium is the fact that you need to know the difference between a gland and a blood vessel. Now, a gland, is a lot more darker, has a darker border to it than a blood vessel. We can kind of see it here, right? This would be a blood vessel, and characteristically it has some blood in it, while this would be a gland. See how much darker the border of the gland is compared to the blood vessel? Now I'll explain why in a second. This is very much repetition of earlier courses, but just to make sure. The blood vessel has these endothelial cells. Now the endothelial cells have very bulging nuclei. However, the cytoplasm is acting as a wall for this blood vessel in general. So therefore the wall of the blood vessel appears a lot more thinner because the only real thing that it's made up of is the cytoplasm of these very stretched and elongated endothelial cells, while the glands have walls made up of these simple cuboidal epithelium or glandular epithelium. Now, looking from afar, these glandular epithelium will appear a lot more darker like they do here, but zoomed in it will actually look more like this. So these are the simple cuboidal epithelium, and zooming out will make the wall of the glands appear a lot more darker, while the blood vessels, which you might see, I think this would be a good blood vessel. See how the walls here are a lot more thinner than the walls of this gland, right? And now that's a very, very important distinction between a gland and a blood vessel, because definitely you could be asked about both here. So therefore, the thicker the wall, the more likely it is to be a gland. While here you can see a thin wall, sometimes you can see blood cells within it. You'll know that that would be a blood vessel. Everything else in this slide is mainly glands because of the glandular or cuboidal epithelium. Yes, okay, now how do we identify if we're looking at a human uterus on the microscope? So for example, here we have the entire human uterus image zoomed out for us artificially. So now we can see the endometrium, and sometimes we can even see most of the myometrium, which you can see here how big it is. The myometrium is made up of the muscle cells or smooth muscle cells of the uterus, while the endometrium has all of these lighter area known as the lamina propria with all of the glands. This is not something you'll see, or this zoomed out, you will not be able to see it on the microscope. Therefore, I'm going to try to explain how to easily identify that you're looking at a human uterus when it's very zoomed in, because that's just how far the microscope goes. Something like this. Now, if you see this very distinct border between muscle tissue and this gland area, which is lighter, then you know for sure that we're looking at the human uterus. This is specifically the border between the endometrium and the myometrium of the human uterus. So again, the only real signifier you can see when trying to distinguish if it's the human uterus slide is this clear, distinct line that they will show you between the myometrium and the endometrium. So remember that. Here you might also see it, so not as much, but this area would be the endometrium, and then this area would be the myometrium. Of course, they'll show you more of the myometrium, but just to give you a general hang of it, again, if you see this border, most muscle tissue here, while you see gland, lighter area here, that is how you know that you're in the human uterus area, right? Okay, so again, that's just how much the microscope will zoom out, and that's how you'll know that you're in the human uterus. This is more myometrium. How do I know that? Because all of these are smooth muscle cells. You can kind of see cross-cut of smooth muscle cells here, elongated cut. It very much looks and appears like muscle tissue. Hopefully that's obvious to most of you. Going back, there are some layers, additional layers within the human uterus besides the main endometrium and myometrium areas. So within the endometrium, we have two separate layers. We have the stratum basale, which is the lower half, or lower third, I would say, of the human uterus, like so. Then we have the stratum functionale, which is the top half of the human uterus. I would recommend you looking towards the stratum functionale area in order to differentiate between the glands, so that you know if you're in the proliferation phase or in the secretory phase. Why? Because in the stratum basale area, even though you're in proliferation phase type uterus, you might see these elongated glands and think, we are in the secretory phase. But in fact, this might be just like the beginning, or a rest product of the secretory phase. We are much more interested in the glands towards the top, or stratum functionale, in order to determine what sort of phase this is, and this is very characteristic of a proliferation phase, right? Okay, that was that. The glands are called the uterine glands. You can write this out like so as well. The area surrounding the glands, or the material that makes up the endometrium, is known as the lamina propria. You can also write stroma if you want. The most important part, though, is that you know the difference between the proliferation phase and the secretory phase, that you know that this is the endometrium, you know these two layers. In the myometrium, however, you have 3 layers. So the first one being the stratum submucosum, that's the area that is directly underneath the endometrium, like so. Then we have the bigger layer, which is known as the stratum vasculare, which hosts all of these arcuate arteries. We'll get to them in a second. And then the bottom layer, which is known as the stratum supravasculare, which is underneath the vasculare layer. The most bottom part of the human uterus is known as the perimetrium. Now, there's going to be a lot of different names with the prefix peri in them. So this is going to be your first one, and it's the perimetrium, which is directly underneath the human uterus. But we have periosteum, we have perichondrium, pericardium as well. But that's more in class 3. We're looking at class 1 right now. Okay, of course, the myometrium is made up of the smooth muscle cells. Other than that, I think we can get into the blood vessels of the human uterus. Now, there are 3 types of blood vessels that is pointed out by Professor Ronne as important, and there are 4 types of blood vessels pointed out by Professor Vijvans. We'll start with Professor Ronne, then we can get to Professor Vijvans. So the first blood vessel pointed out by Professor Ronne is the spiral arteries. Now, spiral artery goes from, according to her notes, or my notes taking her classes, goes from the myometrium like so, and then towards the endometrium, continues up. And when it's cut like this, in order to prepare a slide, the blood vessels appear bunched together almost in a grape-like format, almost like the fruit of a grape, right? Like so. So when you see all of these blood vessels bunched together like so, like a grape, then you'll know that we're looking at a spiral artery. We can also see them at the top of the endometrium. Maybe there's a better example like so. Yep, here we can also see all of these blood vessels. How do I know that these are blood vessels and not glands? Well, look at how darker the border of the glands are compared to the blood vessels. Maybe there's one that's less pixelated, I guess not. But you can see that these blood vessels are also bunched together like so, and that's because they are originally spiral shape, but because they are cut in a way, it appears like they are in a grape format. That was the first blood vessel that Professor Ronne mentioned. The other 2 are the arcuate arteries, which are the very big and obnoxious arteries within the myometrium. They appear like so. This could be an arcuate artery. This could also be an arcuate artery. It doesn't have to be this gigantic. This is a perfect example of an arcuate artery. This could also be one. maybe this as well. So again, very big arteries with very thick walls. Perfect example of the arcuate arteries and the most easiest one to find. Finally, we have the straight arteries, and the straight arteries just appear very, like the name suggests, straight and thin. Here, you can see that they are almost slit-like forms. They have these blood vessels, or blood cells, so you know that we're looking at a blood vessel and not just a artifact. But here you can see a slit-like thin straight artery. Here you can see it as well. That's all for Professor Ronne. Now, Professor Vaivads disagreed with some things. The first one being the spiral artery. Although he does agree that the spiral artery appears like a grape-like bunch or format, he does not agree that we can find them in the myometrium or in this area, right? So while this could be a spiral artery according to Professor Ronne, this would more likely be a radial artery according to Professor Vaivads. Radial artery. And what is the difference between a radial artery and a spiral artery? Well, according to Professor Vaivads, the radial artery is a little bit larger. It's still bunched together like a grape, but it's within the myometrium, not the endometrium. So the radial artery appears radial, according to Professor Vaivads, Professor V, is within the myometrium and appears slightly larger than the spiral arteries. Still the same grape-like format. While the spiral artery is only a part of the endometrium. You can kind of see it here. Now again, this might not be 1000% correct, so double check it with your professors. This is just how I interpreted the student notes taken from the professors. So there might be a lot of lost in translation areas there. So spiral arteries, see how smaller it is than the radial artery. This is a perfect example of a spiral artery according to Professor Vaivads within the endometrium, while this would more likely be a radial artery according to him because of the fact that it's in the myometrium. This is the endometrium. I hope I said that correctly. This again, radial artery, right? The other artery that he mentioned is the basal artery. The basal artery are arteries that are branched away from the radial artery. So if the radial artery went like a spiral toward in the myometrium, the basal artery are branches that goes from the radial artery like so. So every blood vessel that you see that is kind of going away from the radial artery, that might be the basal artery. So for example, this could be the basal artery. If we go back here, this might be the basal artery, or this could be the basal artery. It's very wishy-washy. The arteries are the one area that I studied on the least because it was that unspecified that I didn't want to give it too much of my time. But again, I'm just mentioning the things that I learned just in case this appears as well. He also mentioned the arcuate artery, which is the easiest artery, obviously, the one more deeper into the myometrium that is the largest. And that's that, I think. Those are the arteries of the human uterus. Now going into the demo lab area. If we look at the myometrium here that we have for the human uterus, we can see that we can see a blood vessel here, and this looks more like an arcuate artery. This as well. Why? Because it looks fairly large compared to the smooth muscle cells, and it just appears like it's more deeper within the myometrium, right? Up here we don't really see that many blood vessels, besides maybe this could be a blood vessel, maybe this. They're not very specified, so that's why I'm not gonna try to add that in. I might not even add it in for the test yourself videos, just because again this is not my strong suit when it comes to the human uterus. Also, another thing to point out is because it's because the microscope is this zoomed into the slide, again, take this with a grain of salt, but I doubt they'll ask you about the layers of the human uterus besides the 2 layers in the endometrium, stratum functionale and basale. Maybe stratum submucosa, maybe, but it's hard to find the line where stratum submucosa and vasculare begins, etc. So again, also it's hard to show that line and show that border within the microscope. So that's why I doubt that those layers might come up. Definitely the layers of the endometrium might come up, but not those other layers. I think that's it. They could fool you and ask you about a blood vessel instead of the gland in the endometrium, just to double check your knowledge in differentiating a gland from a blood vessel. But other than that, I think that's it for the human uterus. Now we can get into a little bit about the total chicken embryo, which looks something like this. Now, again, this is an area that wasn't really covered in our colloquium because it wasn't a slide that they said we should worry about. But since it's still in the curriculum, I will bring it up or bring up some areas that I do know about this, this specific slide. Now, first of all, what are we looking at? We're looking at an embryo from, I would say, from above, like a bird's eye view of an embryo. So before we were looking at this section of a human embryo, and this is a transverse section. So what do I mean by that? If we can find me trying to explain. Here we were cutting the embryo in a transverse section, like so, like a cucumber. Even though that's a morbid image to put in your head, just stick with me here. So we were cutting an embryo like so, like a cucumber, and therefore we could see sort of the cross section of the embryo like so. Well, on this image or this type of slide, we're looking at an embryo from a bird's eye view, so from above. Yes, so here we can actually see the neural tube, this, from above, and we can see how far it stretches. So the neural tube isn't just circular, it's very oblong. But in this case, we were cutting the embryo like this, so we were looking at this neural tube from a transverse section, making it appear much like this. But from here we can see that the neural tube is very elongated like so, with the neural canal being in the center like this. And remember the pom-poms that I mentioned here, the paraxial mesoderms or the somites? Well, you can see how many we actually have of them. So here, if this is the neural tube, you can see at the ends of it we have all of these somites. Only here we can only see 2 of them because we were cutting it in this way, right? And following the somites, we have this lateral mesoderm. It's a little bit harder to be able to distinguish it because, again, it's not cut in this way that we can identify it better. But we might see the somatopleura here, I guess. These that I call the fins of the embryo because it looks kind of like a fish from above, right? With this being the rib cage, even though it's not. So the fins are called the vitelline veins, and they appear on both sides of the embryo. We have some more easier structures of this slide. For example, this notch that you see at the top, at the sort of nose of the embryo, is called the neural pore. I almost forgot what it was called. The neural pore. And it's a little notch that goes inwards. You can also kind of see it here as well. So here you can see the vitelline vein more apparent. The neural tube being here, the somites being on either side. Another area that is important are the eye vesicles. So you can see them here on either side. Again, it kind of looks like a fish, right? And if we have the eyes here, we have obviously the brain development or the brain vesicle in the center as well. The notochord, I'm not going to say you can actually see it because I don't. Maybe this is the notochord, maybe not. Maybe this could be the notochord. Again, if we remember how this look, what this looked like, the notochord was underneath the nodal tube, and here we can see the nodal tube, we can see the canal, and maybe underneath that we can see some sort of semblance of a notochord. But again, because it's from above, it's harder to see. Another set of layers that I'd like to mention is the area opaca and the area pellucida, I think it's called. Pellucida? Maybe. Let me double check. Yeah, area pellucida and area opaca. So the area opaca is this, or the area pellucida is this lighter area, like the name suggests, and the area opaca is this more opaque area that is a lot darker. I think that's it. There are some structures that were mentioned in previous students' notes, but that is not as identifiable here. So please, if this is a structure that might come in your colloquium, talk with your professors. But other than that, I think we're done with class 1 finally. Now we can finally get into class 2. So thank you for watching this video, and see you in the next one.